Hey everyone, I hope you're doing well today. In this video, we're going to practice solving 4 different radical equations. Let's get right to it. For this first equation, we have the cube root of 2x plus 7 is equal to 3. Keeping this in radical form, we can cube both sides to cancel out the cube root. When doing so, we get 2x plus 7 on the left and 27 on the right. Subtracting 7 from both sides, we can write 2x is equal to 20, and dividing both sides by 2, we find out that x is equal to 10. While you can solve it in radical form, keep in mind that you can also solve it in exponential form. The cube root of 2x plus 7 is the same thing as the quantity of 2x plus 7 raised to the 1/3 power. To cancel out that rational exponent, we would just raise both sides to the third power. And whenever you have a power raised to a power, you can multiply them, and in this case we get 1. And just like we solved it earlier on the left, we have 2x plus 7 is equal to 27. Again, you can subtract 7 from both sides, divide both sides by 2, and we get x is equal to 10. When solving radical equations, it's always a good idea to check for extraneous solutions. Plugging in our solution of x equals 10 into the original equation, 2 times 10 is 20, 20 plus 7 is 27, and the cube root of 27 does equal 3. In this equation, there are no extraneous solutions. Here's the second example. We have the quantity of x plus 2 raised to the 3/4 power minus 1 is equal to 7. If we were to solve this using radical form, keep in mind that this is the same thing as the 4th root of x plus 2, all raised to the 3rd power, minus 1 is equal to 7. Remember that the denominator of 4 is always the index, and the numerator of 3 will be the exponent. Next, we're going to add 1 to both sides to isolate the radical, so we'll get the 4th root of x plus 2, all raised to the 3rd power, is equal to 8. We can take the cube root of both sides, so we get the 4th root of x plus 2 is equal to 2. The inverse of taking the 4th root of something is raising it to the 4th power, so raising both sides to the 4th power, we get x plus 2 is equal to 16. This is just a one-step equation, and subtracting 2 from both sides, we get x is equal to 14. Now let's take a look at solving this in exponential form. Just like we did earlier, we'll start by adding 1 to both sides, and we'll get the quantity of x plus 2 raised to the 3/4 power is equal to 8. Now what's nice about having it in exponential form is that we can just raise both sides to the 4/3 power because that's the reciprocal of 3/4. Using the power to a power property, these exponents will cancel out to make 1, and we can write x plus 2 is equal to the cube root of 8 raised to the 4th power. 8 to the 1/3 power is the same thing as cube root of 8, which is 2, and 2 to the 4th power is equal to 16, so we can write x plus 2 is equal to 16. Subtracting both sides by 2, we get x is equal to 14 again. Now let's check for extraneous solutions by plugging in our answer of 14. Substituting into the original equation, 14 plus 2 is equal to 16, 16 to the 1/4 power would equal 2, 16 to the 2/4 power would equal 4, 16 to the 3/4 power would equal 8. 8 minus 1 is equal to 7, so this checks out. In this next one, we have x plus 1 is equal to the square root of the quantity of 7x plus 15. The first thing we're going to want to do here is get rid of the square root by squaring both sides of the equation. On the left side, we have to make sure that we're squaring the entire expression, so we're squaring this x plus 1. We have to remember from quadratics that when we square this binomial, we're actually going to have to FOIL and get x squared plus x plus 1, or just x squared plus 2x plus 1. Rewriting this, we have x squared plus 2x plus 1 on the left side, and the right side just becomes 7x plus 15. At this point, we have a quadratic equation, and typically our go-to strategy to solving them is setting it equal to 0 and trying to factor. Subtracting 7x and 15 from both sides of the equation, we can write x squared minus 5x minus 14 is equal to 0. The three methods we really should consider is maybe seeing if we can factor, complete the square, or then use the quadratic formula as a last case resort. Since the leading coefficient is 1 here, let's see if we can factor easily. It turns out that two factors that multiply to negative 14 that add to get to negative 5 are going to be negative 7 and positive 2. So we can write the quantity of x minus 7 times the quantity of x plus 2 is equal to 0. The two values that make this equation true are when x is equal to 7 and x is equal to negative 2. Let's check for extraneous solutions. Plugging in 7 into the original equation, we're going to see if 7 plus 1 is equal to the square root of 7 times 7 plus 15. Simplifying a bit, we'll get 8 is equal to the square root of 49 plus 15, and 49 plus 15 is 64, so we'll have 8 is equal to the square root of 64. And since 8 equals 8, this solution works out. Now let's plug in -2 to the original equation. Let's see if -2 plus 1 is equal to the square root of 7 times -2 plus 15. Simplifying a bit, we get -1 is maybe equal to the square root of -14 plus 15. And that simplifies down to -1 is possibly equal to the square root of 1. And since -1 doesn't equal +1, x equals -2 is an extraneous solution. We got it algebraically, but it doesn't actually work for the original equation. This is an extraneous solution. And for this last equation, we have the square root of x plus 2 plus 1 is equal to the square root of 3 minus x. Unfortunately, we can't isolate either of the radicals, so we're just going to have to square both sides right away. While the right side works out nicely, the left side's a bit messy. When squaring the left side, try not to fall into the trap of just squaring each of the terms. Remember that you actually have to FOIL it. Multiplying it out, we'll have x plus 2 plus the square root of x plus 2 plus the square root of x plus 2 plus 1. We can combine the two square root of x plus 2's and write x plus 2 plus 2 times the square root of x plus 2 plus 1. Combining these constants, we can get x plus 2 times the square root of x plus 2 plus 3. Replacing it on the left side, we have the equation x plus 2 times the square root of x plus 2 plus 3 is equal to 3 minus x. Now that we just have one radical, let's isolate it. By subtracting x and 3 from both sides of the equation, we can get 2 times the square root of x plus 2 is equal to -2x. Dividing both sides by 2, we'll get the square root of x plus 2 is equal to -x. To get rid of the square root, we'll square both sides, so we'll get x plus 2 on the left side, and we'll get a positive x squared on the right side. Hopefully you notice that this is a quadratic equation, so we should set the whole thing equal to 0. By subtracting an x and a 2 from both sides, we can write x squared minus x minus 2 is equal to 0. Just like the last example, we can either try to factor, complete the square, or use the quadratic formula. Lucky for us, this one's factorable again. It factors into the quantity of x minus 2 times the quantity of x plus 1 is equal to 0, and we'll get our two solutions of x is equal to +2 and x is equal to -1. Now let's check for extraneous solutions. Testing out that x is equal to +2, we get the square root of 2 plus 2 plus 1 is maybe equal to the square root of 3 minus 2. Simplifying a bit, we can get the square root of 4 plus 1 is maybe equal to the square root of 1. And simplifying a bit more, we get 3 is equal to 1, which is totally not true, so x equals 2 is an extraneous solution. Now trying out the -1, we have the square root of -1 plus 2 plus 1 is maybe equal to the square root of 3 minus -1. Then we'll have the square root of 1 plus 1 is maybe equal to the square root of 4. And finally, since 2 is equal to 2, we know that x equals -1 is a valid solution. And that wraps up this video on solving some different radical equations. I hope you found this video helpful and you understand how to solve radical equations a little bit better. Keep up the great work, and I'll see you in the next one.